So okay, let's start with this one. Starting with the last question, TK we'll start with this one. The question states that this ethanol it reacts with HCN in the presence of KCN. What changes in bonding occurs during this reaction? So you've got so this one is nucleophilic addition, right? It's ethanol. This is what's happening, right? This is the whole mechanism. I'm going to redraw this for ethanol, which is CH3, C double bond O, carbon being positive, CN minus one. That's the nucleophile coming from the catalyst. It attacks this positive carbon atom, and the electrons get repelled. And the next step, you have O minus one, the CN bonds at the bottom. And finally, you have H plus one, which gets attracted to it. So a carbon-carbon bond is formed. That is true. You got a carbon-carbon bond. The first one is correct. That is what is getting formed. A carbon-hydrogen bond is broken. So a carbon-hydrogen bond is not broken. A carbon-hydrogen bond is broken. This H plus one actually comes from HCN. Okay, that's where this H plus one comes from. So a carbon-hydrogen bond is broken. That is true. The H plus one is coming from HCN. And a carbon-hydrogen bond, the CN bond is never broken. So that is definitely incorrect. Okay, is this clear?
Yes. What about carbon-carbon bond? Can you explain it again?
I mean, this part, that's the first thing that's happening. The CN, the carbon over here joins with this carbon. So when the CN joins up, it's the carbon-carbon bond that's getting formed. Is that clear?
Yes.
As the next one, we've got this question, X turns to Y and Y turns to this thing. What could be the structure of X? Firstly, this one, can this thing be turned into this thing in 2 steps? And what do I need to do if I want to turn this thing into this thing? What is the first step that has to be done?
Oxidation.
Is the first step going to be oxidation, or is it going to be something else? Like if I oxidize this using K2Cr2O7, you got a primary alcohol, right? And that primary alcohol will turn into nothing should happen to the double bond. That primary alcohol will turn into carboxylic acid.
Oh, we'll first change the alkene to alcohol, and then it will turn to ketone and carboxylic acid.
Okay, so the first thing is you would have to do addition because you need OH over here as well. So it will be turned into an alcohol. The double bond would go away. It's going to have OH and H getting added to it, and this one is still an OH, and then you'll further oxidize it.
So to break the double bond, we add concentrated sulfuric acid. No, it's for dehydration.
For that's an addition reaction. This is this reaction. How do you turn an alkene into an alcohol? You add water. Let me make this bigger. As you add water, that's electrophilic addition. 300 degrees centigrade, 60 atmosphere. Phosphoric acid is the catalyst. So you have hydration. Water gets added to this thing. Is that clear?
Yes, sir.
But anyways, that requires 2 steps. Next step is you got a primary alcohol that turns into a carboxylic acid. You got a secondary alcohol that will also turn into a ketone. What about this one? What needs to be if you want to convert this into this thing? What's the first step?
Nucleophilic substitution.
Okay, you have a halogenoalkane, and you need to displace that halogenoalkane with an OH. You have to turn it into an alcohol. Halogenoalkane, you have to bring in an OH. So that's the first step. And this side is already a carboxylic acid, so we don't care about that one. This one turns into an alcohol. The Cl is replaced by an OH. That's the first step. The second step is pretty much the same. You oxidize this and it turns into this molecule. So that is again 2 steps. What about this one? Can you do this in 2 steps?
They're pretty much the same.
It's kind of the same, except you have an aldehyde. So the first step would be the Br gets replaced by OH, and you have an aldehyde. But if you oxidize it, the aldehyde would also turn into, this side over here will also turn into a carboxylic acid, and this side will turn into ketone. So all three are correct. Here, all three of them are correct. So next one, you've got halogenoalkanes listed below all react with NaOH, which reactions proceed mainly by an SN1 mechanism. So which halogenoalkane have SN1 mechanisms? Primary, secondary. Okay, so it's tertiary halogenoalkanes, these ones. The Cl breaks off first, and then the OH ion comes in. So we're looking for a tertiary halogenoalkane. The first one is definitely not tertiary. It's propane, and the iodine is on the first one. So that is a primary halogenoalkane. The other two, they look like tertiary halogenoalkanes. This one is also a propane, so 3 carbon atoms. And it's got, on the second one, it's got an iodo, so that's an I on the second one, and it's got a methyl on the second one as well, so another carbon atom. So this one is definitely a tertiary halogenoalkane. And that one is kind of the same as well, except you have a bromine in that case. So these two are correct. The first one is wrong. So next one, you've got this reaction, and 2-methyl propene can react in more than one way with chlorine. One of the reaction follows the pathway shown. Which statement about this mechanism is correct? So the intermediate has all carbon atoms in the same plane. Is that correct? This one, are all carbon atoms in the same plane? And remember, he's focused on the carbon atoms.
Yes.
You got,
No.
I mean, this, and you have carbon over here, right? And then you have the rest of the bonds, 3 H's with
No,
this one.
I think in the planar shape, I don't think we have them in the same plane.
Remember, this is this molecule, right? So how many pairs of bonds does it have? Does it have a lone pair?
No.
Carbon has 4 electrons, right? Carbon has 4 electrons. 1 electron is being shared over here. 1 is shared over here. 1 is shared over here. One of them is lost. So carbon at the moment has only 3 bonds. The middle one, right? So when something has 3 bonds, what is the shape of that thing? It's planar, right?
Trigonal planar.
Okay, it is trigonal planar. So when anything has only 3 bonds, because remember, there's nothing else. The +1 charge indicates that the 4th electron is lost. So it's going to be trigonal planar. So that makes, so it's going to be fan shaped. The middle one is going to be trigonal planar. It's going to be fan shaped, which would make all the carbon atoms in the same plane. After that, it's not going to be in the same plane, but up till this point, this is fan shaped. Okay, is this part clear? That they do lie in the same plane. Yes or no? Is this clear?
Yes, sir.
So the other one is there's an electrophilic attack on the double bond. Is that true? You've got an alkene, you've got a Cl2. Is there an electrophilic attack?
It's nucleophilic.
The alkenes do have electrophilic reactions. Whenever you have an alkene, I mean, this is how, so this is, one second. So this is how a Cl2 will react. I mean, just like bromination, you've got a double bond. The bromine, one second, the bromine will become slight positive. The other bromine would become slight negative, and it will get polarized because of a repulsion from the double bond electrons over here. And anything that's attracted to electrons or the negative double bond, that is electrophilic. So it is I mean, this thing is an electrophile. So alkenes always have electrophilic reactions. So the second statement is also, there is going to be an electrophilic attack. Is that clear? And it's definitely not a free radical mechanism. I mean, there is no free radical getting produced. So definitely not a free radical. This is what's happening in the whole reaction. Initially, the carbon does not have a double bond, so it doesn't have a positive charge. This is what, there's a double bond. The Cl2 molecule approaches it, its electrons get knocked out. You got a negative chlorine, you got a positive chlorine. The positive chlorine gets attracted to the double bond even more, and it then goes and joins with one of the carbon atoms. Okay, so this is simple electrophilic addition. Is this part clear? This question, yes or no? Is this part clear?
Yes.
sir.
That's the next part. Which properties increase from magnesium to barium? So you're going down the group. Ionic radius, that's obviously down the group. It's increasing, right? Screening of outermost electrons by inner shell, does that increase or decrease?
It increases.
Increase.
It increases. This is shielding basically. You've got more shells down the group. So there's more screening or more shielding. Solubility of the hydroxides also increases down the groups. All three are correct. We've got this reaction, which reaction routes can be used to make a pure sample of barium sulfate. So pure sample, you burn barium. So what is produced? Barium oxide. You put barium oxide into dilute hydrochloric acid, you get barium chloride. Then sulfuric acid is added. A precipitate of BaSO4 is going to be formed. Although there's not going to be any reaction, but barium ions, this is soluble, this is soluble. Soluble things will mix up. Barium ions and sulfate ions will combine to form a precipitate of barium sulfate, which is insoluble. And that can be filtered off and washed away. So what about, so I think that works. You got barium sulfate at the end. Now, barium nitrate is strongly heated. It will decompose to form what? Barium oxide and a bunch of gases.
Dioxide and oxygen.
Okay, so the solid one is going to be barium oxide. That is mixed in an excess of water. So barium oxide is soluble. So it will form barium hydroxide.
And then barium sulfate.
Okay, so you get barium sulfate again. It's insoluble. And so what is this one? This is going to be barium nitrate.
Yes. Which is soluble, and then barium sulfate. It's all.
So all three are making barium sulfate. Except I guess all three are I only have doubt with this one, but since they are talking about strong heating, so I'm assuming that it will decompose, because decomposition becomes harder down the group, but it will decompose. I mean, they're using the word strong heating. We've got this question of factors affecting the rate of reaction. Remember, the question is on rate. Sodium thiosulfate and hydrochloric acid can be investigated. The ionic equation, which of the following can be used to investigate the rate of this reaction? So remember, how do you measure rate? Rate is, you measure how quickly a change is happening with respect to time. And that change could be anything. It could be mass changing. So this one. Can you measure the rate of this equation or reaction by measuring?
Yes.
So why is the mass changing?
Because no, it won't, because there is no gas. Nothing is going to.
There's nothing is going to escape the container, right? Everything, I mean, you'll get new things, but they will still be part of the container. So the mass is not changing, right? So you can't measure the rate because the mass is never going to change. And make sure you make this point that you can only use mass if the mass is changing. And usually that happens when a gas is getting formed. Change of appearance caused by formation of a precipitate. Can you do that? Will there be a change of appearance?
Yes, because there is a solid.
There is a solid. And then usually what happens is, how do you measure the rate of this reaction? You measure how quickly the change is happening. What you do is, initially the solution would be colorless because it's going to be aqueous, right? And as soon as the precipitate would form, the precipitate would make the solution very opaque. light will not be able to pass through it. So what you do in the lab is that you place a printed page underneath it, and you have a stopwatch, and you measure when does the printed page, which is at the bottom of the beaker, when does it disappear? If it disappears very quickly, like in the first 10 seconds, that means the reaction is very fast. If it takes a very long time to disappear, then the reaction is very slow. So this will definitely work. And change of electrical conductivity, can you do that? Will that change with respect to time?
Yes,
Yeah,
because
that will. And why would that happen?
because they're solid which won't conduct. And
Yeah, because you have ions, and ions do conduct, right? But these are covalent molecules. They don't conduct. So electrical conductivity would be very high initially, but then it will slowly decrease with time. So there will be a change that will happen, and you can measure how quickly that change happens. So only the first one is incorrect in that case. So next one, you've got which statement are correct for all exothermic reactions? All delta H for reaction is negative. That is obviously correct. On a reaction pathway diagram, the products are shown lower than the reactants, and the reaction will occur without heating. Are all three correct or not?
Second is correct.
Okay. What about C? The reaction will occur without heating.
It's not possible.
no,
I say it's not going to be correct because you have activation energy. Like when you want to burn something, right? That's an exothermic reaction, but that requires heating. Just hold on one second. We get a call. 1 second. As I said, can you hear me?
yes, sir.
Hello. So this one, the reaction will occur without heating. I mean, combustion is one reaction. Like you want to burn a mass, that's exothermic, right? But it will not happen without heating it first or burning wood. Every reaction has a certain activation energy. If you don't give it that energy, the reaction will not start, whether it's endothermic or exothermic. Now, which molecules and ions have a bond angle of 120? The first one, what is the bond angle in BF3? B is in group 3.
120. 120.
So it only has 3 bonds, no lone pairs. It just has 3 electrons in its outer shell. What is the shape of CH3 minus 1? Let's say if somebody is going to ask you about CH3 minus 1, what is the shape of
107. Trigonal.
Exactly, because pyramidal. It's going to be, you have CH3. Remember, carbon has 4 electrons in its outer shell, right? So that means there's a 4th electron, which is not bonding. And since you have a -1 charge, that means there's 1 extra electron as well. So basically, it's like NH3. It's got a lone pair and it's got 3 bonds. So it's trigonal pyramidal, and its angle is 107. NH3 is exactly the same. N has 5 electrons, 3 of them are bonding, and you have 2 electrons left. So that's exactly the same shape. It's 107. So only 1 is correct. Which ions contain 1 or more unpaired electrons? So for this, you have to do the whole transition metal thing. It's copper has 29 electrons. So 2p6, 3s2, 3p6. What comes after 3p6 for copper? Like if you want to write, it's 29 electrons.
4s1.
Because it's going to be 4s1 and 3d.
Or 3d.
And remember, the 3d is full in the case of copper. It's a special case. And if you have +2, that means 1 electron is gone over here, 1 over here. So you do have unpaired electrons. What about? I'm not.
Because 3D has higher energy than 4s.
He doesn't have higher energy than 4s. 3D has lower energy than 4s. I'll explain this. Remember, I've explained this several times, but let me do this again. Remember that the OFO principle, when you're filling electrons, right? You fill electrons based on a table. Okay? So that table does not really signify the energy levels. I mean, you have an OFO principle, right? 2p and then you have, sorry, not 2p, this is 3s, and you have 3p, and you have 4s and 4p, and then you have so in this case you have 2p as well, and so on. You make these diagonal arrows, and that's how you fill electrons. So remember, this is just a way of filling electrons. It doesn't really tell you what the order of the or the energy levels are. For transition metals, remember this, the 4s has a higher energy. It's the outermost shell compared to 3D. It's only for potassium and calcium that the 4s actually has a lower energy. Because in the case of calcium, the electronic configuration after 3p6, it's 4s2. There is no 3D. So that thing, the thing that you where the 4s has a lower energy compared to 3D, that only works for calcium and potassium. Otherwise, for transition metals, it's always 3D having a lower energy compared to 4s. But you're going to follow the principle over here. You're going to fill the 4s, and then you're going to fill the 3D. But energy-wise, 3D is going to come. It's going to have a lower energy. Is that clear?
Yes, sir.
Okay, so remember, for transition metals, 3D is lower compared to 4s. But you're going to fill the 4s first, then the 3D. So what about Mn? Mn, how many electrons does Mn have? I think it has 20. 25. It has 25, right? 25 means 4s2, and that's 20, and 3d5. So you automatically have, and it's plus 3, so that means 2 electrons over here, 4 left. So that is unpaired. 3d4 is unpaired. And vanadium, what is scandium vanadium? That's, I think, 22. So 23. What would 23? Scandium, titanium, and vanadium. Okay, so it's 23. So 23 is going to be 4s2 is 20, and then you have 3d3, right? So it's going to be 4s gone and 1 from here as well. So you still have unpaired electrons. So I think all 3 of them are correct. All of them have unpaired electrons. Is that clear?
Yes.
So this one you've got. So what does this represent? This thing?
E double bond O.
So this thing has a serial bond O, and that's pretty much it. There's no broad and peak broad absorption at 3000. There's no absorption around 3500 for alcohol. So there's nothing else. So it definitely has a serial bond O and no OH whatsoever. So there's no OH. What are the structures? So let's read the question first. J is a branched chain alcohol. It's a branched alcohol. Remember that. It's heated and reflux with Cr2O7 until no further reaction occurs. An organic compound K is formed in good yield. Infrared spectrum of K is shown. So this is the product of the oxidation.
Oh.
So which alcohol gives you serial bond O when you oxidize it?
Ketones.
Okay, so it's going to be a secondary alcohol, right?
Yes.
So secondary alcohols, they form a ketone. Primary alcohols will turn into a carboxylic acid. So that's so this is not a carboxylic acid. So anyways, J is a, so what are the structures of the branched alcohol J and compound K? So it's a secondary alcohol. This one is a ketone, right? So secondary alcohol. Which one of these do you think is a secondary alcohol?
The third one, C.
C is not. I don't think C is a.
I think B.
OH is on the second carbon.
I mean, I'm doing this one first. C. Then you have another C, and this one has a CH3 branch, right? And then you have another C, and you got H and OH. So there's an OH, and then you have another C, right? So this is a secondary alcohol, right? Two
Yes.
carbon chains. And that is also a ketone, right?
Yes.
So what's wrong with B then?
It makes a tertiary alcohol.
D has
B is
carboxylic acid.
What is B? Is B a primary, secondary,
Okay,
or tertiary?
B is tertiary.
tertiary.
Hey, it's secondary B. Look at B. It's 1, 2, 3. On the third carbon atom, there's an OH branch, right? And after that, there's 2 more carbon atoms. So this one is a secondary alcohol, right? So B is also a secondary alcohol. Plus, it is also turning into a ketone. So that's also correct. So, I mean, based on the information, both of them look to be correct. The only difference is that initially they told us that J is a branched chain alcohol. So this is not a branched chain alcohol. This one is. So the answer is going to be C. Is that clear?
Oh, yes.
Yes.
TK, otherwise B was fine as well, but the first statement wasn't. TK, just remember, whenever you read your MCQs, read them very carefully. TK, if you do them very quickly, I mean, underline everything. TK, although this was very relevant because you would have gotten the wrong answer, because the first one you would have tried would be B, and you would have quickly. So make sure you underline things very clearly so that you don't miss on anything. I say we've got this question, and it's heated with an excess of sodium hydroxide. What molecule is this?
Ester?
Okay,
Ester.
so what will NaOH do? It's going to break down the ester, right? So both ester groups will break down. This will turn into what? It will turn into
Carboxylic.
carboxylic acid, right?
Carboxylic acid.
But since it's alkaline hydrolysis, it won't turn into carboxylic acid. It will turn into a salt of the carboxylic acid. So it's going to be these two, right? Is that clear?
Yes.
And this part will turn into alcohol. So that is true. But alcohols don't react with alkalis. Remember that. Alcohols have no reaction with alcohols react with Na, but they don't react with NaOH. Anyways, this other part would also form a carboxylic acid, but that would form similar to this, but it would react with the alkali to form a salt.
And I'm not getting why it's sodium attached, like salt.
Because carboxylic acids react with it, because you've added an alkali to it. It's alkaline hydrolysis. So this thing will form, right? I'm not saying that this thing will not form, but you have NaOH. What happens when carboxylic acids and NaOH react? They end up forming, and there's an excess of NaOH, right? So they will end up forming a salt. Is that clear?
Yes.
So the next one is you've got this molecule is reduced using in excess of LiLH4. What is the organic product? So this is a carboxylic acid, and carboxylic acids, they do undergo reduction with LiLH4, and they will probably turn into aldehyde, and then they will further get reduced to an alcohol. So you'll have a double alcohol. You'll have an alcohol on this carbon atom, on this one as well. So you had a carboxylic acid, but now you'll have alcohol on both sides. So it will turn back into, it can also turn back into an aldehyde as well. But since they're using an excess of lithium, so I'm guessing an aldehyde is out of the question. What is the name of this molecule?
Ethane 1,2-diol.
Okay, so it's going to be B. So next one is which compound shows optical isomerism and gives a iodoform test. It's supposed to have an alkaline iodoform test. That's true for, you need
Methyl.
these two structures. Methyl with a acetyl bond O, or a methyl with a CHOH. And then you have the rest of the carbon and hydrogen atoms. So first one, it's supposed to be chiral as well. The first one, will it give you a positive test for iodoform?
Yes.
You got a CH3 next to a acetyl bond, so that's true. And it looks chiral as well. Like if I draw the first one, it's CH3 acetyl bond O. Then I have CH and I've got an OH as well, and I've got a CH3. So it is chiral. I mean, this carbon has 4 different groups attached. So that is definitely chiral. So I guess that's fine. There's nothing wrong with this. This one is not chiral because every carbon has 2 hydrogens. And this one has a double bond, so it can't be chiral. The other ones won't have a positive test. So is this clear? The first one is correct.
Yes.
So now the next one is you got sodium reacts with 1 mole of compound Y to produce 1 mole of H2. Which compound could be Y? So 1 mole of H2. So if sodium reacts with it, this alcohol H is going to get displaced. So you'll have the carbon chain followed by ONA. And only one H is getting displaced. So half moles of H2 is going to be produced. So that the first one is not correct. Because to form 1 mole of H2, 2 hydrogens need to be displaced. The second one is also not correct. The third one is also not correct. It's going to be D.
Because can you explain this one again?
If sodium reacts, remember this, sodium reacts with the alcohols to displace the H over here, and it also reacts with carboxylic acids. And it's going to displace the OH in the carboxylic acid as well. So it's going to react with both. So if sodium reacts, you'll get a sodium over here, you'll get a sodium over here as well. So your product is going to be CH3, CH and O minus 1, Na plus 1 instead of OH. And then it's going to be COO minus 1 and Na plus 1, right? So how many H's got displaced? 2 of them, right? So if you balance it, it's going to be 1 mole of H2. Is that clear?
No, sir.
Clear or not? I couldn't hear you.
It's not. Can you explain why
said
the other 3 are wrong?
I said, what about this one? If sodium is going to react with it, right? So the H in the carboxylic acid is going to be displaced. So you'll have what? CH3, CH2. And then you'll have another CH2, and then you have COO minus 1 and Na plus 1, right? And metal reacting with a carboxylic acid will produce salt plus H2, right? Yada, clear? Is this part clear?
Yes.
Now, when you balance it, how many H's got displaced? Only one of them, right?
Yes.
So if I want to balance it, there's going to be half of H2 gas produced, right? I mean, you can try balancing the whole equation. So is this part clear that only half moles of H2 gas would be produced? Because only one H got displaced.
Yes, sir. Understood.
So basically he was asking for 1 mole of H2. So all the others, it's going to be half H2 getting displaced. Only this one, there are 2 H's displaced. So there's going to be 1 H2 gas molecule being produced. As you got this reaction and excess NOH and what happens when you have ethanolic NOH?
It turns into alkene.
It turns into an alkene. The Br is going to be displaced. The Cl and the Br will be gone. And you'll have double bonds on either side. You can't probably have a double bond on this side because the H has to be lost from the other carbon atom as well. Like whenever an alkene is formed, the Br is lost and the H is lost from the neighboring carbon atom. The neighboring carbon atom over here does not have an H. It already has 4 bonds. So the double bond is definitely going to be over here on this side. Is this part clear? That you'll get a double bond on this side, not on the other side. So that's the first thing. So the double bond would be on this side. So it's either B or D, right? I said, what about this one? The Cl is going to be displaced, and the H needs to be displaced from the other side. Everything looks, just one second. What's the difference? So it's going to
Is
be
it
this
B?
one. It's going to be B. Cl is going to be displaced. And the H will be displaced from the neighboring carbon atom. So double bond would be over here. The Br will be lost and the H will be lost from the neighboring carbon atom. So the double bond would be over here. So you'll have double bonds here, double bonds here. So I guess that is B, right? Is that clear?
Yes.
So then you have an organic molecule W contains 3 carbon atoms. It requires 4.5 molecules of oxygen for complete combustion. So basically you have to make a balanced equation. My guess is it's the first one. C3H8. It's going to form 3CO2 plus 4 H2Os. And it's how many oxygens? It's 6 plus 4, 10. That's 5 O2s. It's 6 plus 4, that's 10. So not the first one. Probably propanoic acid then. What is propanoic acid? C2H5? So what do you get for this? It's 3 CO2s and 3 H2Os. So you got 3 2s are 6 plus 3, 9. 7, 3.5. Still getting the wrong one. So, I mean, you can check the other ones. Maybe it's D. But you can do this. You would have to balance the whole equation. And then you can, we can quickly try C3H7OH. So 3 CO2s, 4 H2Os, and that's 10 oxygens. So this is going to be 4.5. So this side has 10 oxygens, and there's 1 oxygen already over here, so you need 9 oxygens. So this is going to be 4.5. That's the answer. D is the answer. So anyways, moving to the previous one, the conversion of propene to propan-2-ol can be carried out in 2 stages represented by the equations shown. And so this is an addition reaction. Double bond HI gets added to the double bond. This one is a displacement reaction. The iodine gets displaced by OH, nucleophilic substitution. So addition and substitution, that's it. Moving, this one is slightly tricky. Is this part clear? This one?
Yes.
So now the other part is that a new jet fuel has been produced that is a mixture of different structural isomers of compound Q. Which skeletal formula is a structural isomer of Q? It has to be an isomer of Q, right? What about the first one? Is it an isomer or not? It's 1, 2, 3. To be an isomer, you have to have the same number of carbon atoms. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You got 14 carbon atoms. It's an alkane. You can count the hydrogens as well. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So they have the same number of carbon atoms. Are they isomers? Are they arranged differently or not?
Yes, they are arranged differently.
Q is cis and A is trans, maybe.
No, you don't have cis trans when there is no double bond.
The branches.
Oh, okay.
Plus, they're looking for structural isomers, not stereoisomers. As anyways, the structure has to be different. They have to be arranged differently. So, are you sure they're arranged differently?
No.
They're not. They're exactly the same. Because if you look over here, like if I number them 1, 2, 3, 4, 5, 6, 7, everything looks exactly identical. 1, 2, 3, 4, 5, 6, and 7, right? Up till, I mean, the second one has a carbon branch. The second one over here also has a carbon branch. The third one has a carbon branch pointing downwards. That's everything matches, right? The difference comes at this carbon number 7, right? At 7, you got a carbon branch, a single carbon branch. Let's call that 8. Over here at 7, you got another carbon branch, single one, that's 8. So that also has that branch, right? And this 7 also has another branch. Let's call that 9, 10, and 11. The 3 more carbon atoms. This 7 also has the same one. 9, 10, and 11. It also has the same one. So structurally they're exactly the same. This atom over here is bonded to the same things. This one is also bonded to the same thing. So structurally they're exactly the same. Is that clear?
Yes.
Yes, sir.
So then let's move to the other one, because remember, for structural isomer, it has to be arranged. The atoms must be bonded in a different way. So let's talk about B now. Does it have the same number of atoms? 14, right?
It has 13.
This one?
Yes, 13B has.
Okay, so that's out of the question. What about C?
It's C then.
It has 14.
Wait a second.
D is also the same.
Yes,
Then
C and D have
1, 2,
14.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Same carbon atoms, but I do believe that this is arranged differently, right? Because if I start at, I mean, this is definitely arranged differently, because there's a carbon with 2 carbon branches, there's a carbon with 2 carbon branches, there's another carbon with 2 carbon branches. Over here you have just 2 of them. Over here you have 3 of them. So that's on the third carbon atom you got a bigger branch. So the arrangement is different. So I guess C is correct. What's wrong with D?
It's exactly the same. It's just split in one of the carbon branches.
It's exactly the same.
Yes, the branch is only in the lower one.
Because if I start from this side, this is 10. Let's call this 9, and this is 11. TK, we're matching with this one. You got 7 and 8. And then you have 6, 5, 4, and 3. So up till this point, up till 3, everything matches, right? At 3, you have a single branch, right? So you have a single branch over here as well. And at the same 3, you have this double 2 branches. You also have this 2 branches on this 3 as well. So these 2 are exactly the same. So the answer for this one is going to be C. So moving to the next one, you got C5H12O. It's a branch skeletal carbon atom and secondary alcohol functional group. So how many structural isomers fit the description? So it has to be branched. That's the first thing. So I'm going to draw a 5 carbon atom. I guess it's an alcohol. They've told us it's an alcohol. So it's got to be branched. It has to be branched. So that's one. What other branches can I have? I can have. So these are the 2 versions of the branches that I can have. Then I have to make it an alcohol. And now this one can have many positions for the OH group. It could be over here. It could be on the middle one.
Sir, but wouldn't it be a tertiary alcohol then?
Okay, I'll come to that at the end. As anyways, the OH could be over here. So this particular branch will have these options. This one will have only one place to put the OH, and that's at either of the, all of them are the same. So you got these 5 possible products, and it has to be a secondary alcohol. Is this a secondary alcohol, this one?
No. Primary.
That's a primary, because the carbon is only bonded to 1 carbon. This one is primary as well, right? What is this one?
Secondary.
Second.
That's a secondary. This one is primary, and this one is tertiary. So you got only one that fits the description, that it has to be a branched alcohol and it has to be a secondary alcohol. So only one of them is actually matching the description. As this one, what is true of every nucleophile? That's it attacks a double bond. Is that true? or it donates a pair of electrons, or it's a single atom, or negatively charged. Which one is true?
D, I guess. Oh, D.
B.
D.
It's needs B. Needs B. Remember, a nucleophile does not necessarily have to be. A nucleophile is something that's attracted to what charge, positive or negative?
Positive.
It has to. I mean, the complete definition is that it's attracted to positive charge, and it can donate a pair of electrons. Now, NH pair of electrons. Now, NH3 is one example. It's not negatively charged, although a lot of nucleophiles are negatively charged. The OH -1 is negatively charged. The CN -1 is negatively charged, but not every one of them is negatively charged. So this one is not entirely true. Is that clear?
Yes.
So you've got transition elements and the compounds are widely used as catalysts. What is the identity and what is the oxidation number of the catalyst used in the contact process? So
D.
Vanadium plus 5.
okay, so it's vanadium pentoxide. And next one is the statement explains the observation of magnesium hydroxide dissolving in ammonium chloride. Again, this is a lot of questions come on this one. So explain to me what will happen if it reacts with ammonium chloride. What will be the reaction?
Magnesium chloride will form
And what else?
ammonia gas and water.
So you have this reaction. But then the question states that magnesium hydroxide does not react with NaCl. So what's the best explanation for this? Why does it react with ammonium chloride?
Because it is acidic.
Yeah, because so it's going to be D. Ammonium, remember, ammonium ions can donate an H+1. That's why it turns into NH3. It's an acid-base reaction, this one. This is a base, OH-1, it accepts an H+1, turns into water, and NH4+1 loses an H+1, turns into NH3. So the NH4+1 is basically an acid, or it can behave as an acid. That's why it reacts with bases. Is that clear?
Yes.
Now, chlorine reacts with cold aqueous NaOH to form solution Z. Solution Z is heated and forms ClO3 -1 and Cl. Which equation, first one, what will happen when Cl2 reacts in the cold with NaOH?
It forms ClO, not ClO3.
It forms a, one second, let me open the. This one forms a ClO -1, right? So it's either option C or D. What's the next one? When you heat it, it's forming ClO3 -1. Reaction number 2 in both cases appears to be, I guess it's. So which of the reaction number 2 is correct?
D?
This one. The B is out of the question because it doesn't form ClO2 -1.
D1, the last.
And why is that? Why is that correct? Like, what is the oxidation state of Cl over here? That's +1, right?
3.
What is the oxidation state over here? That's +5, right?
5.
And this is -1. So that means if I try to balance this equation, this goes from +1 to +5. So that means it lost 4 electrons, right? And the same Cl goes to, that means it gained 2 electrons, right? And that needs to be multiplied by 2. So that, I mean, the equation is perfectly balanced. So that makes sense. That it looks to be balanced. So D is, I think, correct. But what about C? Is that balanced as well? It's ClO -1 is +1. This is +5. So that means it has lost how many electrons? 4 of them.
4.
And how many is it gaining? It's going from +1 to -1. So it's gaining 2 electrons. So the electrons gain and lost are not equal. So this equation is not balanced. Is that clear?
Yes.
That's Cl +1 goes to +5, loses 4 electrons. Cl +1 also goes to -1. So that means it gains 2 electrons. And the equation electron-wise is not balanced. This one is balanced. Cl +1 goes to +5, so that's a loss of 4 electrons. Cl +1 goes to -1, that's a gain of 2 electrons. But there are 2 of them over here, so that's a gain of 4 electrons. So this equation is balanced. So option D is going to be it's going to be your correct option. TK, is this part clear?
Yes.
Yeah.
Now the next question correctly describes the properties of the halogens as group 17 is descended from chlorine to iodine. What's the answer to this one? Volatility decreases or increases?
Decreases.
Increases.
Decrease.
Becomes harder to boil
Okay,
something.
sorry, yes. Decreases.
TK, they don't evaporate easily down the group. Iodine is a solid. What about oxidizing agents down the group? Weaker or
Decrease.
stronger?
Decreases.
TK, they don't like to gain electrons down the group. As the next one, you got a sample of calcium nitrate is placed in a test tube and heated in a roaring Bunsen flame until it decomposes. So it is decomposed. The description of the gas in the test tube then noted. A glowing splint is then put into the test tube and any changes are noted. So you got calcium nitrate.
Nitrogen
So-
dioxide is a brown gas and oxygen will relight.
So both things will happen. You'll have a brown gas, right?
Yes.
And the splint will relight because you're getting both things. So what is SiO2 and SiCl4? Which one is what type of bonding do they have? Covalent or ionic? Together, the non-metal, so it's covalent. A giant covalent or simple covalent?
Giant for SiO2 and
ठीक है.
simple for SiCl4.
So remember this. This is giant covalent, and this one over here is simple molecular. SiCl4 is a colorless liquid. Remember that as well. X and Y elements in period 3 of the periodic table. The oxide of X is a solid at room temperature. The oxide has a giant structure. Whose oxide are we talking about? Period 3.
Aluminium.
Yep, that makes sense. Any other one, which is a solid and has a giant structure.
MgO.
SiO2.
So you got MgO as well. You even got SiO2 as well. That's a giant covalent structure. It's a solid. And I guess we can also include sodium oxide as well. All of them, they're all ionic, except for SiO2, which is giant covalent. The last two are excluded because sulfur dioxide and phosphorus oxides are not giant structures. The chloride of X does not react with water. So which one is there?
Cl2O3 or SiO2?
The aluminium chloride reacts vigorously with water.
Oh, sorry.
NaO won't react.
SiO2.
That also has a vigorous hydrolysis. SiCl4.
Na2O.
Na2O.
And
So this is option C, I guess.
so you have NaCl, right? NaCl does not react with water. So this is either Na
Sure.
or it could also be Mg. Because, one second.
So does it have a giant structure? Na2.
It's ionic. All ionic lattices are giant ionic lattices. I mean, everyone has a giant structure. Metals have giant structures. Giant covalent structures are also giant. Ionic compounds are also giant. The only ones that are not giant are simple molecules. So I'm pretty sure it's Na, right? But Mg is also a candidate because MgCl2 also hydrolyzes very, very weakly. Argon is the only element with a lower melting point than Y. So that means it's got a pretty low melting point. So that's Na. And that's going to be your answer. Na, remember, has a very, you can melt a group 1 metal on your hands. It has a very low melting point. So let's quickly, sodium and sulfur are burned separately. What are the flame colors?
Yellow for sulfur and white for sodium.
Sulfur will get blue.
Sulfur is blue, I guess. Sulfur is
Yes,
blue.
it is blue, and sodium is yellow, so it's C.
Yeah, yellow. Can you
So you guys-
send the table or any data about these color?
Just 1 second. I mean, this is the same sheet. It's I'll send that. Open this on WhatsApp. So you're not. So open this on your laptop. So the colors. Where are the colors written? That's they're talking about. So this one. Na has a yellow flame, the first one, and sulfur has a gentle blue flame. So these are where the flame tests are given. So anyways, the next one is question number 11. So which equilibrium, which statement must be true for Kp of the equilibrium to be constant? The partial pressures are equal. If you want to keep Kp constant, should the partial pressures be equal or not?
Sir, I think we have missed the questions. It's 9.
I'll just show you this one. I think I've missed this one. First do this one. A finely powdered iron catalyst is used in the Haber process. That's true. And a vaporized tetrachloromethane catalyst in ultraviolet light is used. Which statement of the catalyst used is correct? Both use a heterogeneous catalyst. Is that true?
No.
For the Haber process, that is true. Iron catalyst is a solid. But for depletion of ozone, the catalyst is it's a CFC. Tetrachloromethane is a CFC, and that CFC is also probably in the form of a vapor. So that is not heterogeneous catalyst. So the first one is wrong, and both of them are not homogeneous catalyst because the first one is heterogeneous. Reaction 1 uses heterogeneous catalyst, and reaction 2 uses homogeneous.
Yes.
That kind of looks correct. The reaction number 1 is heterogeneous. Next one is you've got 0.2 moles of sulfur. So this is the table thing. It's 0.2 moles of sulfur dioxide, 0.2 moles of oxygen, and there is no sulfur trioxide. At equilibrium, there is 0.1 moles of SO3. So you got 0.1 moles of SO3 at equilibrium. So that means 0.1 mole got produced or formed. So if you want to form 0.1, because you had 0 and now you have 0.1, so 0.1 got formed. So if you want to form 0.1, how much of O2 must have reacted?
0.05.
So 0.05 must have reacted. And 0.1 of SO2 must have reacted as well. So this is going to be 0.1 and this is going to be
Sir, how is it 0.1?
0.15, right?
Yes.
So I'm just going to repeat. These are the initial moles. And it was given that 0.1 moles of SO3 is getting formed. To form 0.1, 0.05 must have reacted, 0.1 of this must have reacted according to the ratio. So 0.1 over here are gone and 0.05 over here are gone. And you're left with, out of 0.2, 0.1 are gone, so you're left with 0.1. Out of 0.2, 0.01, 0.15, 0.05 is gone. Now you have to find Kc for this, and the Kc would be product concentration. So it's going to be SO3 squared divided by our reactants, which is 0.1 squared. So this and divided by 0.15. So what do you get for this?
D.
Yes, so we are getting D. And this one now, which statement must be true for Kp to be constant? To keep Kp constant, what needs to be done? If you want to keep the equilibrium constant.
A.
Temperature should be constant.
D
You can
option, I think.
Remember, Kp only changes with? It
Temperature.
only changes with temperature, that's it. Otherwise, no matter what happens, the Kp value is not going to change. The pressure should, there's no need to keep the pressures equal. Maybe a lot of pressure for HI, a lot fewer pressure for H2 and I2, but that's irrelevant. Kp will not be affected by that. As a transition metal ion M dichromate 6, it converts M4 plus to Cr3 plus. Which equation represents this reaction? So again, you have to, it's a redox reaction, you would have to balance it accordingly. So for example, if I start with the last one, that's a loss of 2 electrons. Cr is plus 6 over here. That means it's a gain of 3 electrons, right? So I'm going to multiply one of them by 3 and the other one by 2. So there's going to be 3 M's and there's going to be 2 Cr2O7s, right? 2 of them. And 3, so that would make it 3, right? So that is not the equation. The equation is not balanced properly. Is that clear? The last one isn't. There should have been 3 M's, which you don't have.
So is it C?
Just C has, how many electrons are gained? M2 plus 2, M4 plus, that's 2 electrons, right?
2 electrons are
Lost?
lost.
Okay, so 2 electrons are lost and you got 3 of them. So that's a total of 6 electrons getting lost. Cr goes from plus 6 to plus 3. So that's a gain of 3 electrons, but you got 2 of them. So that's a gain of 6 electrons. So this equation looks to be balanced electron wise, right? Is that clear?
Yes.
Yes.
And so then you have so that is the right one. C is the right one. Now I've got this equation which will correctly changes in oxidation number. You can what's the oxidation number over here for sulfur?
+4.
And where does sulfur change to? What is oxidation state of sulfur over here?
+6.
That I think is +6. So that's loss of -2, right? What happens to N? What is N over here?
+5.
Okay, so it's +5 over here, and I guess it's +3 over here. So that's +2. So the answer to this is B.
So you switch nitrogen with sulfur, I guess. Yeah.
Sorry, yes, I did. I guess that's the only option I have left. Which row shows the correct changes? No, I didn't actually. +6 to +4. What's the? It's an increase by +2, right? So sulfur goes up by +2. +5 to +3, so the change is -2, right? So B is still the correct one. As the next one, you got enthalpy of combustion, and he says that try and solve this one and give me the answer. What's the answer to this one? So what is the minimum mass of butane? First thing is calculate how much energy goes into the water. C, remember, is 4.18. What do we get? Q is equal to MC delta T.
91,960.
91,960.
Yes.
And it's going to be negative because the temperature is rising. That's the amount of energy that is produced. So anyways, this is the amount of energy required to do all of this. So, and he's also said that only 47%, this is just 47% of the energy. Because they've stated that only 47% of the energy is actually goes to the beaker. So 47% of the energy is this thing, minus 919. So what is 100% of the energy? What do you get for this?
So how are you getting minus 91?
The MC delta T, that's M, C, delta T.
Okay.
3,678.
For X?
Yes.
Why is it lesser?
Sir, मेरी value तो बहुत बड़ी आ रही है.
हाँ, बड़ी होगी. You're going to get a bigger value.
195659. Anyone confirm it?
Yep, same.
Only 195659?
659, yes. 0.57.
That's remember that's in joules, right? It's simple ratios, crisscross. It's 47% of this is this. I mean, 47% of the energy actually goes over here. So the 100% of the energy that is produced by butane at the bottom, that's this. We found that. And remember, this is in kilojoules. So it's basically minus 195 kilojoules. If I want to convert it into kilojoules, it's going to be minus 195. Now the last part, they've given us the enthalpy change of combustion of butane. So 1 mole of butane produces this much energy. So I know that 1 mole butane, it produces, how much does it produce? 2877, right? This thing. So 1 mole butane produces 2877. I guess there was another 7. There's just 4 of them. Kilojoules. How much do we have? We've got 195.66 kilojoules. So again, use ratios. Figure out how many
Sir,
moles do you...
नहीं 195 dot. अच्छा आपने kilojoules में convert करके किया?
हाँ.
Okay.
So this one, they gave us the enthalpy of combustion of butane. So the 1 mole of butane produces this much. So if I want to produce this much energy to heat this water, so how many moles of butane would be used? I mean, again, use ratios.
0.068.
Yes, sir.
So you're getting 0.
0.068.
0.068. And that's moles of butane, right? You have to multiply it by the MR of butane, which is because you have to give the answer in grams. So the MR of butane is what? C4H10.
58.1 is MR.
So did they give us the MR? They did give us the MR. So multiply it by the MR and
3.9.
how much?
3.95.
3.94.
Okay, so C is the answer. One more thing. 4.18 is the specific heat capacity of water. So you have to remember that. Now it's going to be given with the question. Not sure why it's not given over here, but it should be. I mean, you should know that it's the specific heat capacity of water, 4.18. So is this question clear? The question was slightly tricky that you had to. The first thing was we did the energy of this, measured how much butane energy went into this, but that was only 47% because they told us that only 47% is absorbed by the water. So 47% is this one, So 100% of it that's being produced when you're burning butane is going to be, you're going to use ratios, and we figured out that came out to be minus 195.6 kilojoules. And this is kilojoules now. And then the enthalpy of combustion of butane was given. 1 mole of butane produces this much. So this much would be produced by how many moles? We found those moles and we multiplied by the MR to figure out C. TK, is this question clear to everyone?
Yes.
So next one is we've got PV is equal to nRT. What mass of sample of methane given two significant figures? So I guess you just have to plug in the values. Units have to be carefully taken. The pressure is 103 kilopascals, so that's 000. The volume is already in meter cube, so that's 5.37 times 10 power minus 3. And N is the moles. How do you find moles? That's mass divided by. We'll find the moles. Then we'll find the mass. nRT. R is 8.31, and temperature should be in Kelvin. So that's 333. Can somebody confirm that's it, right?
Yes, it's 333.
So now what's the answer now? How many moles?
0.199.
Yes.
0.2 moles, right?
0.02.
Okay, so, and you multiply it by the MR of methane, which is 16. And we don't have this answer.
0.32.
That's still not, we don't have that answer. Did we?
So answer is C.
Sir, is the answer C?
Are you getting exactly 3.2?
Yes.
That's
I'm
why I
getting
got
3.
3.1.
No, it's 0.32.
0.32 is 0.32 is not an option.
But when we multiply 0.02.
Sir, from where did we get 0.02 moles?
I'm getting 0.2.
This is somebody told me you got 0.02 moles.
I didn't get 0.02 moles.
It's wrong.
Yeah, and after multiplying my moles with 16, which I don't remember now, I got 3.2.
The mole is 0.19.
0.199.
Yeah, something like that.
So that is 0.02, right?
Oh. Sir, for 16 से C आ रहा है.
But no, when we are getting mole 0.0199 and then multiply by 16 and 0.319. So it's 0.32 basically.
0.32 is not an option.
Yes, but still we are
Aren't
getting
the moles 0.2?
Yeah, not 0.02.
0.02. No, sir, it's not 0.2.
Just a second.
So
Can you
जी.
check the markings?
तो 0.199 नहीं आता था, उसके अंदर वो आता था, लेकिन उसका सिर्फ 0.2 आता था, 0.02 नहीं आता.
You're getting 0.2.
It's C.
TK, you're getting 0.2 for this.
Yes.
So yeah, I'm pretty sure you're getting 0.2 for this. That's the next one. We've got 5 gram sample of all these, and they're getting decomposed. And for which compound is the greatest loss in mass? Now this one, 5 grams each. You don't have to really do any calculations. All of them are 5 grams, right? So which one will produce the most amount? All of them will have, I think, will have the same equation. Like barium carbonate will decompose to form barium oxide and carbon dioxide, and they've added lithium carbonate as well, which would pretty much do the same thing. It's going to form lithium oxide and carbon dioxide. But anyways, the equation is the same. So how do you solve this without doing all the calculations? The greatest
Divide
loss.
them by their MR.
Remember
Greatest
moles.
moles.
Remember moles is mass divided by MR, right? So who's going to have the greatest moles? Whose MR is bigger or smaller?
Smaller.
Smaller.
And if you have the greatest moles, then you'll have the greatest amount of moles of carbon dioxide as well, right? So you'll have more moles if the MR is smaller. So who has the smallest MR out of all of them? I think it's,
Lithium.
but there are two of them. Can you compare? Can you calculate magnesium carbonate and lithium carbonate both?
Okay.
I think it's still lithium. It's this is 24 plus 60. That's 84. Lithium, I think it's 7. So I guess it is C. Without doing any calculations, 5 grams of lithium carbonate, because the MR is the smallest, it will have the greatest moles. So it will have a lot of moles. If this has a lot of moles, the carbon dioxide moles would also be very, very large. So a lot of carbon dioxide gas would be produced. Is that clear?
So we're going to select an
Yes.
option with the lowest MR.
Because the greatest loss in mass is because of more carbon dioxide being produced. And when is more carbon dioxide produced? If you have more moles. So who has more moles? The one that has the smallest MR, right? Is that clear?
Yes.
So now this one, is saying that a sample of C6H12 is burning. It's completely burned. So C6H12 is going to produce carbon dioxide and water in the same ratio. Like if you balance this equation, it's going to be 6 carbon dioxide and 6 water molecules getting produced, right? So the water and carbon dioxide ratio would be exactly the same. Is that clear? That this thing will produce both things in the same ratio. This one is absorbing water. This one is absorbing carbon dioxide. So if 6 water molecules are absorbed over here and 6 carbon dioxide molecules are absorbed over here, how will the mass of the two tubes change? So we have to figure out the ratio. MP is this one. So 6 water molecules, that's 6 into 18, right? So tube P, its mass will increase by 6 into 18. Tube Q is 6 into 44, right? So I guess I get 18 over 44. Which is the correct option?
A.
G. A, yeah.
You guess it's A. So I've got this one. What is basic assumption of kinetic theory as applied to an ideal gas? Which one is the correct one?
Their collisions are elastic.
A.
The first one is correct. This one is obviously wrong. He's talking about the basic assumption. Can somebody check? This one is not as applied to an ideal gas. Can somebody just confirm this one, whether it's you have negligible intermolecular forces. I mean, there are two main basic assumptions. This assumption is also correct, but the two main basic assumptions are that you have weak intermolecular forces or negligible intermolecular forces. Or almost
Negligible intermolecular force.
but you would have to confirm this one. And the other one is that the volume occupied by the gas particles is negligible compared to the volume that is occupied by the gas.
For one, is it C?
For one, this is going to be, it is C, it's in group 3, right?
No, but it says from a filled shell. That means
So this one, the first 4 ionization energies of element X are shown in the table. The first 4. So it is which group is it in? It's in group 3, right? What's the electronic configuration of group 3? That's S2 and P1, right? Because this is in group 3. It's got 3 valence electrons. Now he's saying that which ion of X is produced by removing an electron from a filled shell? From a filled shell. This is an incomplete shell at the moment. And he's talking about the whole shell. Like if let me take an element of aluminium that's in group 3. It's 1s2, 2s2. Then you have 2p6, 3s2, and 3p1. Now this is the outer shell. It's not complete. So the first 3 electrons would be lost, right? And it will form 3 plus. Now this is 3 plus. Once it forms 3 plus, then an electron is removed from a filled shell. So 3 plus is fine. Because the outer shell would be gone and you're removing electrons from, I mean, the outer 3 electrons are gone. And now you're removing electrons from a filled shell. Is that clear? So C is correct. And remember, read the question carefully. Even in this one, there was little chance of making a silly mistake, because even if you go for group 3, it's going to be X3 plus. But sometimes they would have a similar question and they'll say, which ion is formed when where electron is, which ion of X is produced by removing an electron from a filled orbital? If that was the question, what would be the answer in that case? If instead of
+2.
+2 or +1, because the first electron is removed from an half-filled orbital, right?
So that gives +1.
+1, and then when it becomes +1, then you're removing electrons from a filled orbital, right? So it's going to be +1 in that case. So just make sure the questions can be tricky in this. Just read this carefully. In this case, it didn't really matter, because even if you just thought, if you did it very quickly, just don't try to do things quickly. Read the fine print. Okay? Read the things that are. I mean, this thing really matters. I mean, you would understand the question, but you'll still get the question wrong because you didn't read the question properly. Okay? So make sure you read the questions properly. Okay? So let's continue tomorrow with another paper. Okay?
Yeah.
Yes.
Sir, from October, November 17, 1-2 variant.
Just
Sir,
1 second.
before that, could you explain question number 11 of this same paper again?
This one?
No, sorry, 13.
13 is the oxide is. So the oxide is a solid at room temperature. So all of these are solids. Ionic, giant ionic, giant ionic, giant ionic. This is giant covalent. So all of them are solids. And they all have giant structures. The chloride does not react with water. So Na and Mg are the ones that don't react with water. Mg does. MgCl2 hydrolyzes very weakly. NaCl absolutely does not hydrolyze. And Isha, I'll send you a screenshot. So argon is the only element of period 3 with a lower melting point than Y. Sodium has the lowest melting point. It has one of the lowest melting points in the. I mean, this is. I'll show you the. 1 second.
Isn't sodium X?
So sodium is X, right? Sorry. Okay, so sorry. This is. I forgot about Y. Just a second. Argon is the only element in period 3 with a. So he's talking about Y basically. I didn't read the question properly. It has a lower melting point than Y. So who has a lower melting point than Y? That's Cl2. So it still makes it NaCl. But I'll show you the graph over here. Argon has the lowest melting point. The only one greater than that is Cl. Did he mean that? Argon is the only element with a lower melting point than Y. That is true. So that is Cl. Is that clear?
Yes.
Okay, so that still makes sense. What was the other question?
Sir, October, November 1712 variant.
Which question?
Sir, question 15.
So there's 3.705 kg of substance Y are needed to neutralize 100 moles of HCl. So, it's a time-consuming question. It's 100 moles of HCl, right? In all cases, with calcium, it's going to be 2:1. So this is all going to be 50 moles. I mean, the reason I'm not making an equation is that every time calcium chloride would be formed, like if I do a reaction of calcium carbonate with HCl, I know calcium chloride would be formed and water and carbon dioxide. So when I balance it, it's going to be 2 HCl because calcium chloride has 2 CLs. So HCl and this thing will have 2:1. I mean, even if you put calcium hydroxide or calcium, every time it's going to be 2:1. Is this part clear? The first part?
Yes.
Now the next part, you have to figure out the mass of this thing. So this is 50 into 40.1. This is 50 into 56.1. That's the MR. This is 50 into 74. What's 17, 34, 30, 74.1, I guess. And this is 100.1. So who is 3.7? That's, I guess, this one. Is that clear?
Yes. Yes. Yes.
So any other questions?
No, thank you.
Chalo, theek hai. So let's continue tomorrow then.
Allah
Okay,
Hafiz.
Allah Hafiz.